This video will discuss question 33. Suppose that the SR latch in figure 6 is in state Q is 1 and we want to reset it by making R and phi equal to VDD. In what modes are transistors Q4, Q7 and Q8 at the moment when the potential at node Q is decreased by 0.2 volts? And then we get 8 options for states for these 3 transistors. Let's first have a look at figure 6 and try to find the 3 transistors that we need to investigate. We need to have a good look at transistor Q4, Q7 and Q8. So that is these 3 transistors. So since we are going to have to evaluate some voltages in this circuit, it helps if we first make a small sketch of this subcircuit. So let's do that first. We are currently in a state where Q is 1, and that means that the gate voltage of this PMOS transistor therefore has to be 0 volts. Because the other side of the latch to which this gate is connected will be in the opposite state. So this will be ground and this will be VDD. We are now trying to change the state of Q, and to do that we need to conduct current through this path of Q8 and Q7. That means that the gate source voltage of these transistors needs to be set to high. So these are VDD, or in other words 1 volt. And in the question it has been told to us that we're going to look at the moment when the potential at Q has been decreased by 0.2 volts. And since it used to be in the high state of 1 volt, that means that this is a voltage of 0.8 volts currently. Let's start with transistor Q4. Q4 is a PMOS transistor, so it helps if we first evaluate the source drain voltage. The source drain voltage is the voltage between VDD and node Q, and that is 1 volt minus 0.8 volts, or in other words 0.2 volts. And the overdrive voltage of transistor 4 is the source gate voltage minus the threshold voltage. In this case the source gate voltage is 1 volt minus 0 volts, so that's 1 volt minus the threshold voltage for an NMOS transistor, which is 0.3 volts, and that is 0.7 volts. So we now know that the overdrive voltage of transistor 4 is larger than the source drain voltage of 4. So that means that this transistor cannot be in saturation. To find whether transistor Q4 is turned on at all, we also need to evaluate the source gate voltage separately, which we already did. That is 1 minus 0 volts. And since that is larger than the given absolute threshold voltage, that means that the transistor has to be turned on. Since the transistor is turned on and it cannot operate in saturation, Q4 is operating in the triode region. Finding out the operating mode of Q8 and Q7 is a little bit more complex, because there is no easy way to evaluate the voltage at the node between these 2 transistors. So we are going to need a completely different approach to this question. These transistors are connected directly after each other. That means that we can also look at them as if this were one big transistor with a double channel length. So if we were to draw this on a physical level, it would look like this. We would have a p-doped bulk and some n-doped channels, of which the middle channels are connected directly. One of the NMOS channels is connected to ground, and the other one is connected to a node of 0.8 volts. That's node Q in our case. The leftmost transistor would then be transistor Q7, and the rightmost would be transistor Q8. Let's first look at the operating mode as if this were one big transistor. So, what would be the source drain voltage of this big transistor 7 plus 8? It would be 0.8 volts minus the ground, and that is 0.8 volts as a result. And what would be the overdrive voltage of this big transistor 7 plus 8? Well, it would be the gate source voltage, and we just wrote down in the figure that the gate voltage is 1 volt, so that would be 1 minus the source voltage. Now the source voltage of this big transistor would be the ground, so that's 0. And we then have to subtract the threshold voltage, and that is 0.3 volts. So that is 0.7 volts. And finally, we have to evaluate the gate source voltage to find out whether this transistor is turned on at all. And that gate source voltage again is just 1 volt at the gate minus 0 at the source because it's grounded, so that's 1 volt. That is larger than the threshold voltage, so that means that it is turned on. And we now also know that the source drain voltage is larger than the overdrive voltage. So this big transistor would have to behave as if it were in the saturation region. If we now look at our physical interpretation of this big transistor, that would mean that the channel would look something like this. These are NMOS transistors, so these channels would carry mostly electrons. And these electrons flow from the ground to the Q node. So the channel would be widest here and be smallest here. Now, the pinch-off region would be in Q8, here. So that means as a result that Q8 itself will also behave in the saturation region. But something interesting happens in Q7. This channel has been divided into two, and that means that it doesn't end in a pinch-off region. So Q7 is not behaving in pinch-off, therefore it's behaving in the triode region. So Q7 behaves in the triode region because the channel is not in pinch-off, but Q8 is behaving in the saturation region because it ends in this pinch-off.